This is video 4.1.2, and the goal of this video is to look at some arc lengths. These are going to be real applicable to the long-term solving problems with angles. So first of all, the first equation that we need to understand. When we remember radians, radians are an angle that intercepts one radius. So that's why in this picture, for instance, if this purple was one radius, then of course this angle would be 1 radian, right? Because that's the definition of a radian. So if I had theta radians, then I'd have theta radiuses, because if I had like 10 radians, then of course that would mean I'd have 10 radiuses that would stretch around this circle. So this equation then should make sense, that we simply defined the segment length, S, that's what S is described as here, we simply times it by the number of radians, because, well, that's how many radiuses I would have in that particular problem. So if we take a look at when we're given degrees in this problem here, we simply change it to radians by timesing it by using the proportion value. I'm just modeling the proportion one. We'll cross multiply 120 pi equals 180x. And of course, solving for x, we divide by 180, and we get x equals, when we simplify, we're going to get 2 pi over 3 after dividing top and bottom by 60. So that's the number of radians that is equal to 120 degrees. Now, using this equation, this idea, we simply times that by the number of the size of the radius, because that's how many radiuses I want to go around, 2 pi over 3 radiuses. So now I'm simply going to times it by 7, because that's how big a radius is, to get my answer, which is 14 pi over 3 inches. Now, of course, we can change that to a decimal value in order to find the actual distance. And in doing so, we'd get 14.66 inches. Now let's take a look at another example. This next example is a tire on a bicycle that has a radius of 16 inches. So I'm just copying down the formula on the previous page, which says do the radius times the radians to find the segment length, S. So what's the distance traveled if we pedaled the bike 4 pi over 3 radians? Well, if we did 4 pi over 3 radians at 16 inches on the radius, as the radius, we simply do radius times radians to get the segment length. So it's going to be 64 pi over 3, which is approximately 67.02 inches. Now, what if the radius changes to 20 inches? Well, we simply change the value of the R value and we multiply by 20 instead, and we notice we get 80 pi over 3s, which is 83.8 inches. So by adding 4 inches onto the radius of the bicycle, we now have 16 more inches traveled during that distance of 4 pi over 3 radians. So here is your multiple choice and your free response question. Now the free response question, I want to make one thing clear. It talks about 8 revolutions per minute. So if it's 8 revolutions, I want you to understand that 1 revolution is 1 full circle. So of course 8 revolutions is 8 full circles. So see if you can figure out how far it is traveling in distance in feet per minute as described here. Do your best to try and answer that question. And then of course your multiple choice question as well. So bring those questions into class. Thanks for watching this short little sweet video. We're going to be applying some of this stuff in class tomorrow, so hopefully if you have any questions, bring them in.